All right, here's our next example. And in this problem, we're trying to find this limit. And what that means is that we want to find the limit of this function as x approaches 4. So what that really means is we're trying to find how close to a number this gets as x goes to 4. Does it actually go to a number? And if it does, that number would be called the limit. Many times it would be referred to as L. Now, if we do a direct substitution, that would be your first line of attack, so to speak. A direct substitution of 4. Okay, now this works in some problems, but not all. It depends on the function and it depends on the limit value, the limit point here, which is a 4 in this case. So what we have, if you were to just let x be 4 in that expression, you would get this, which is 0 over 0. This is considered indeterminate. Indeterminate. Okay, indeterminate. So, now, that doesn't mean the limit doesn't exist, but it means we have to do a little work to figure out what it is. So one approach then is to find numerically what does this expression get close to as x gets close to 4. Here we saw what it equals when x is 4, basically undefined. Okay. Indeterminate is another way of saying undefined. So when x is 4, it's undefined. All right. The limit is indeterminate. Okay. We don't know yet if it's undefined. We'll have to do a little more searching, but right now, a direct substitution yields that it's indeterminate. Okay. Now the function is undefined. This function. This is undefined at x equals 4. But when we're trying to find the limit, we really don't care what it is at 4. We're just worried about what is it near 4. So this is what we'll do. We'll look at our calculator now. We'll go ahead and put in our function. And we'll look at table. Now, even before we do that, we can look at the graph. Let's sneak a peek at the graph. Okay, so what we're interested in is right over here somewhere, around that 4, somewhere over here. So we might want to do a zoom. We'll do a zoom. We can do a zoom in. It doesn't matter. We'll do a zoom in and we'll get closer to that 4 right in there. That looks pretty good. Okay, now if we trace, notice what happens right at 4. You have a blank for the y. It's undefined right there. That's what it means. There is no value. Calculator's way of saying that is just leave it blank. But if you just go immediately to the left at x equals 3.93 or 94, you see y does exist. It's about 1.26. And if you go immediately to the right, just a little bit bigger than 4, it's 0.124. So it appears that it might be, the answer might be around 1.24, 25, 23, okay, 24, 25, 26 maybe, but I'm not sure. You can see couple values right around 4 there. What's happening to the y value? So I just sort of go past it. Okay. So let's see what that looks like on a table. Let's check our table out. And we can start anywhere we want here. Let's start at, let's say 3. Okay, this, I have to go on and fix that. My table set. I want this on ask, independence, the x. And we can start, let's say 3.7. Okay, now let's go to our table. And the delta table, we can actually have it fit that too. Let's do that as 0.1. In fact, let's make it a little smaller. Let's make it 0.01. And then we'll go to our table. Let's go back here. Table start 3.7. Okay. I guess it doesn't make sense to have that on ask if we're just going to do this. I'll put it on auto. And then let's go ahead and put that table. Okay, so there it is, 3.7. And what we'll have to do is kind of like scroll down. Okay, notice what's happening with the x, the y, and the x. So x is 3.88, and here's y, 1.27. Okay. So we get closer and closer to the 4. Notice the y values are shrinking. They're getting a little smaller. And that means, let's see, it looks like it's getting closer and closer to 0.12. Oh, and then it went to error. Now what happens right after the 4? 0.1248, and right lower, 0.125. So if this is all I had, and I had to make an estimate of what my limit would be here, I would go with 0.125. Okay, that's a preliminary. I would say from here, this, if I had to give a number, I'd say 0.125 from the table. Okay, so again, that table in here, notice that forward's an error. That doesn't mean anything to us because we're looking for the limit. So we got 0.125 as our, apparently what the number is here. Now, if you're still not convinced, you could go in a little deeper, check through that table set. Instead of 0.01, you might say, well, let's make it 0.001. And let's start at, yeah, 3.95 is good. So let's go to that table then. And notice how now we're changing in the hundredths place. Sorry, thousandths place. 0.3. Yeah, what did I set that to? 0.001. Yeah, okay. So, and notice how close we are to 0.125. And if you scroll down here, closer, 98. Seems to be decreasing. There it is, moment of truth. 0.12498, 0.12502. Split the difference, you're at 0.125. So our hunch seems to be, at least in terms of the calculator's numbers, seems to be backed up by this information here. So we got a 0.125, and we'll be happy with